Myopia, nearsightedness, causes, control. 1. Myopia and eye diseases induced by the progression of myopia. 2. What factors cause myopia? 3. Flicker, impact, and detection. 4. Early myopia control. 5. High-frequency flicker has the same impact as low-frequency flicker. 6. Why does flicker induce myopia? 7. Why do different lamps have flicker light? 8. Why do photos of lamps with flicker light show stripes of light and dark that are not visible to the naked eye? Nearsightedness, or myopia, is a condition where close objects are clear, but distant objects appear blurry. Left is normal vision. Right is myopia. Based on research from Ohio State University, 35.7% myopia people will experience the worsening of their nearsightedness at least negative 0.75D. Real-life data of a young Australian boy's eyesight deterioration without myopia control. Without control, myopia can progress to high myopia, which is associated with problems such as retinal detachment, glaucoma, and myopic macular degeneration. These complications will result in significant vision loss. Myopic maculopathy is also known as myopic macular degeneration. People with any degree of myopia have a 100 times greater risk for developing myopic maculopathy. Those who have high myopia have more than 800 times the risk. This image shows how a person with cataract sees. People with high myopia have a 4.55 times higher risk of developing cataracts, and it is estimated that the number of cataract cases will increase by nearly 20 million from year 2010 to year 2030. The left side shows the image seen with normal vision, while the right side shows the image seen by eyes with macular degeneration caused by high myopia. The risk of developing macular degeneration is 13 times higher for people with mild myopia, 72 times higher for those with moderate myopia, and 845 times higher for those with high myopia. From year 2010 to year 2030, the incidence of macular degeneration in the United States will increase by 1.5 million. The left side shows the image seen with normal vision, while the right side shows the image seen by eyes with retinal detachment caused by high myopia. What's the root cause of myopia? Some people say myopia is determined by genetics. That means parents with myopia have children with myopia. But parents without myopia also have children with myopia. Some people without myopia in childhood, but with myopia when growing up. So that shows myopia is not determined by genetics. Myopia increases the risk of glaucoma, cataract, and retinal detachment, and cause of vision impairment and blindness in myopic macular degeneration. Based on data from the International Institute of Myopia, every 10 years, the population of myopia will increase 5%, 600 million globally. The human germline mutation rate is approximately 0.5 times 10 to the power of negative 9 per base pair per year. That is 0.0000005% every 10 years. So the increase is not related to genetic factor. What factors are causing the rapid increase of myopia? Based on the paper published on the Lancet, smart device screen time alone or in combination with computer use was significantly associated with myopia. What are the stripes of light and dark on screen of smartphone and computer in the photo captured by iPhone 2? Flicker light. Straps on screen or lamps are flicker light. In visual perception, flicker is a human visible change in luminance of an illuminated surface or light source, which can be due to fluctuations of the light source itself, or due to external causes, such as due to rapid fluctuations in the voltage of the power supply, power line flicker, or incompatibility with an external dimmer. Flicker light. The light's brightness keeps changing. Most of flicker light's brightness changes continuously in a periodic manner. Research showed that flicker light will induce myopia. Hospital of Nantong University in China found myopia can be induced by low-frequency flicker light in B6 mice. La Trobe University in Australia found low-frequency temporal modulation of light promotes a myopic shift in chicks. Fudan University in China did research and drew conclusion. Myopia can be induced by 0.5 Hz flicker light in guinea pigs at puberty. How to detect flicker? 1. Take a photo of a light source with an old version of a smartphone like iPhone 2. If there are stripes of bright and dark, there is a flicker. 2. Measure the voltage waveform of a light source using the AC coupling mode on an oscilloscope. If the voltage is above 1 mV, there is a flicker. 3. Measure the percent flicker and flicker index of a light source using an instrument, a light meter, that measures brightness. If the percent flicker is above 0%, there is a flicker. 1. Take photo of a light source with iPhone 2. The left one is an incandescent lamp. The middle one is a fluorescent lamp, and the right one is an LED lamp. There are horizontal stripes with alternating light and dark shades. What are the stripes? Flicker. The listed websites showed iPhone 2 photos of all lamps from different supermarkets. Every lamp photo has stripes, so almost every lamp on the market has flicker. iPhone 2 photo of a zero flicker lamp. No stripes with alternating light and dark shades. The lamp can be found on www.uprlt.com. If smartphone photos have no stripes of bright and dark, that is no flicker? No. Some new version of smartphone cannot detect the flicker. Why? The new anti-shake function will record several images and show the page with averaging pixel processing. And some smartphone has anti-flicker function. Both the functions will remove the stripes of bright and dark. Then oscilloscope or light meter can be used instead to detect flicker. 2. Measure the voltage waveform of a light source using the AC coupling mode on an oscilloscope. The peak-to-peak voltage is 3 volts. That is above 1 millivolt. The lamp flickers a lot. This used to be a best-selling LED desk lamp online. After the lamp is opened, the voltage across lamp beads is measured with an oscilloscope. The lamp from Bright Quantum LLC has AC peak-to-peak voltage almost 0 volt. That means no flicker. Refer to www.uprlt.com. Department of Energy. Energy Star used percent flicker and flicker index to measure flicker. The light is measured with a light meter. A is the peak value of the bright light. B is the value of the dimming light. Area 1 is the area of bright light above the average light. Area 2 is the area of dimming light under the average light. So percent flicker equals to 100% times A minus B over A plus B. Flicker index is area 1 divided by the sum of area 1 plus area 2. If the percent flicker and the flicker index are smaller, then the flicker is smaller. How to measure percent flicker and the flicker index? We must use a light meter. For example, exterior light meter. We place exterior light meter in front of an object under test and start flicker measurement with layered software. An incandescent lamp is an electric light that produces light by heating a filament until it glows, using a glass bulb filled with a vacuum or inert gas to protect the filament. The percent flicker is 5.1%. Flicker index is 0.01. Fluorescent lamps work by passing electricity through a macular vapor gas inside a tube, which produces ultraviolet light. This ultraviolet light then hits a phosphor coating on the inside of the tube, causing it to glow and emit visible light. They are known for their energy efficiency and long lifespans compared to incandescent bulbs. The percent flicker is 28.4%. The flicker index is 0.07. A compact fluorescent lamp, also called compact fluorescent light, is an energy-saving light and has a compact fluorescent tube. The percent flicker is 5.1%, and the flicker index is 0.01. A light-emitting diode is a semiconductor device that emits light when current flows through it. LED lamp has percent flicker 54.7% and flicker index 0.17. Smartphone, computer, and smart pad percent flicker measurement. From the waveform, we know maximum value A is 1, minimum value B is 0. So according to percent flicker formula, A minus B over A plus B, that is 1 minus 0 over 1 plus 0. So the percent flicker is 100%. National Lighting Test Center tested the lamp from Bright Quantum LLC. Percent flicker 0%. Flicker index 0. There is absolutely no flicker. Refer to www.uprlt.com. The light is measured with a light meter for percent flicker of different light source. From the table, we can see the minimum percent flicker 0% comes from Bright Quantum LLC, and the highest percent flicker 100% is smartphone, computer, smart pad. So highest percent flicker of 100% explained smart device screen time alone or in combination with computer use was significantly associated with myopia, published on Lancet. Myopia is characterized by the inability of ciliary muscles to relax and thin out the lens when seeing distant objects. The focal point is in front of the retina. The blue one is lens. Percent flicker with respect to myopia. When an individual is exposed to artificial light for a long time while performing complex tasks, a higher percent flicker can lead to increased eye fatigue. The higher the percent flicker, the greater the change in brightness, which means that as the pupils contract and dilate, the changes in pupil area are greater. The ciliary muscle experiences more fatigue. Myopia develops more quickly, and the progression of myopia accelerates. With early myopia control, the progression of myopia is very slow and can be kept at a mild level. If not controlled, myopia can quickly develop into high myopia. Zero flicker lamp impact on vision. The ciliary muscles cause the pupils to dilate in the dark and contract in bright environments. Flickering light constantly changes in brightness, causing the ciliary muscles to alternately relax and contract, which leads to fatigue and loss of elasticity. As a result, they cannot swing the lens to see distant objects. The greater the pressure on the ciliary muscles, the faster myopia progresses. Zero flicker lights have no brightness changes, so the ciliary muscles do not continuously relax or contract, which can minimize fatigue and help prevent or slow the development of myopia. To prevent myopia or myopia worsening, percent flicker must be reduced as much as possible, ideally 0%. People should read under a lamp with 0% flicker. For smartphone or computer with high percent flicker, a lamp with 0% flicker can be used together to minimize percent flicker. That is a way of early control. Use lamp with 0% flicker with a phone to minimize flicker. Smartphone percent flicker is 100%. Zero flicker lamp with smartphone percent flicker is 4.7%. Combined use reduce percent flicker from 100% to 4.7%. Research from Department of Ophthalmology, Jeju National University Hospital, Jeju-si, Korean, got a conclusion. A daily 1-hour increment in digital screen time was associated with 21% higher odds of myopia. The percent flicker decrease from 100% to 4.7% will decrease 21% higher odds of myopia to 1%. Some lighting manufacturers increase the flicker frequency above 1000 Hz, claiming that the human eye cannot perceive it, and calling it flicker-free, an eye protection lamp that cannot protect eye. When intensely flickering light exceeds the comfort level of the pupil, energy accumulates and causes the pupil to contract once a threshold is reached. We will demonstrate that whether the frequency is low or high, the accumulated energy is the same. The 60 Hz flicker is represented by the blue curve, and the 1260 Hz flicker is represented by the red curve, while the straight line at 0.701 indicates a comfort limit. When the light brightness exceeds 0.707, it enters the discomfort zone. Area 1 represents the cumulative brightness discomfort energy within 1 cycle of 60 Hz, and Area 3 represents the cumulative brightness discomfort energy within 1 cycle of 1260 Hz. The flicker frequency is 60 Hz. Cumulative discomfort energy value region 1 is 8.05 times 10 to the power of -4. The flicker frequency is 1260 Hz, with accumulated discomfort energy 21 times that of Area 3, the same as Area 1, 8.05 times 10 to the power of -4. The accumulated luminance energy that causes discomfort is the same regardless of frequency. The number of times the pupil dilates and contracts is the same regardless of frequency. Increasing the flicker frequency does not reduce eye fatigue, nor does it reduce ciliary muscle fatigue, so it does not lessen the impact of flicker on myopia. Let's find the reason why the flicker will induce myopia. The pupil responds to bright light or dim light. You can see pupil constricted in bright light, pupil dilated in dim light. At pupil dilation, pupil size is bigger, ciliary muscle relaxes, lens shape thinner, so can see far object. At pupil constriction, pupil size is smaller, ciliary muscle contracts, lens shape rounder, so it can see near object. Let's find out why flicker induced myopia. Pupil constricted in bright light, then ciliary muscle relaxes. Pupil dilated in dim light, then ciliary muscle contracts. The flicker changes light from bright to dimming so frequently. The ciliary muscle relaxes and contracts so frequently. In the long run, the ciliary muscle will lose flexibility to relax and contract to adjust the lens shape to the original shape. Myopia is characterized by the inability of ciliary muscles to relax and thin out the lens when seeing distant object. Chronically tense ciliary muscles cause the focal point of light to be too far in front of the retina rather than focusing directly on it, which results in blurry vision. Root cause of nearsightedness, due to fatigue of the ciliary muscle leading to a loss of elasticity, is unable to adjust the anterior-posterior axis of the lens, causing distant objects to be focused in front of the retina rather than on the retina. How to prevent myopia? Maximize the reduction of fatigue in the ciliary muscle. Why different lamps have flicker light? Incandescent lamp uses an AC voltage. The voltage waveform shows the voltage across the lamp. Vertical axis YT is voltage. Horizontal axis T is the time. When the voltage reaches the peaks, the light is at its brightest. When the voltage crosses the 0 point, the light is darkest. This varying brightness over time is exactly what flicker is. Why fluorescent lamp also has flicker? Because fluorescent lamp also use an AC voltage. The waveform shows the voltage across the lamp. Vertical axis YT is voltage. Horizontal axis T is the time. Similarly to the incandescent, when voltage reaches the peaks, the light is at its brightest, and when the voltage crosses the 0, the light is darkest. That induced flicker. Some people say LED has DC voltage on it, so there should be no flicker. Really? On the left diagram, that is the voltage waveform across the LED lamp. You can see, although the LED uses a DC voltage, there is a small voltage ripple on it. Then we can take a look at right side. The current with respect voltage function for LED has an exponential relationship, as in the right graph, meaning small voltage ripples from point VA to point VB will cause a huge fast change in current from IA to IB. The brightness of the LED is dependent on its power, which is defined by the expression P equals to I times V. I is current, V is voltage. The square area IB times VB is much larger than the square area IA times VA. So brightness of point B is much larger than brightness of point A. The voltage ripple from point A to point B cause flicker. Why people's eye cannot detect the stripes of flicker? Because of the 0.1 second time for persistence of vision. POV. When you draw a circle with a flashlight at night, what we see is a light circle, not a moving light point. Flicker light is periodic variation in light brightness, causing alternating bright and dark stripes to appear along the light wave's propagation path. The top diagram is a waveform of the flicker light, and the bottom diagram is the brightness path of the flicker light in space. The strong light points on the waveform in the top diagram correspond to the white striped areas in the bottom diagram, while the weak light points on the waveform in the top diagram correspond to the gray striped areas in the bottom diagram. The stripes of bright and dark can be captured by a digital camera and an old version of smartphone. It is responsible for our brain smoothly blending the individual frames at a different time point because of persistence of vision. The top diagram is a flicker light propagation path at 0.01 second. The middle diagram is a flicker light propagation path at 0.02 second. And the bottom part is a flicker light propagation at 0.03 second. So the 0.1 second persistence of vision for a human eye will mix all the above. 0.01, 0.02, 0.03 second to be a plain photo, shown on the fourth diagram. Not bright, not dark. That is why human eye cannot detect flicker, but a camera can.